So welcome to the fifth lesson in Unit 2. And so I noticed in class that we are struggling with factoring. So that's why I did these. So what we do is we're going to factor the GCF, which is the greatest common factor from each of these. So between 3 and 12, what number goes into both of them? And I see 3 is a factor of 3, and 3 is also a factor of 12, which means that 3 goes into 12 with no remainder. Here I have m squared, so two of them, and here I have 1m. So what is common is 1m, so I'm going to take that and factor it out. And now I'm going to write down what's left, right? So if a 3 is gone, right, and an m is gone, I have 1m left, so that m is going to go here. Then I have a minus sign, and over here I have 12 divided by 3, which gives me 4, and the m is gone, right, because it's already over here. So my final answer is going to be 3m parentheses m minus 4. Done. Okay. Here, what is common? -5. The more you do this, the easier it'll become. So if I take out the -5, right, divide both sides by -5, that's going to be a 1 and just a p minus, and -5 divided by -5 is a positive 1. Okay. And I could check my work by doing distributive property, right? We know what that is. So you can go doot, doot, and that'll give you this back, which it does. All right. So this here is our final answer. Factoring each polynomial, as soon as you see something that has like 3 terms, I'm going to encourage you to go like this, multiply, add. So the b term, right, goes on the bottom always, and this number right here, the 5, goes on the top. So we're looking for two numbers that multiply to be 5 and also add to be -6. So the only two things that multiply to be 5 are 5 and 1, but they have to add to be a negative number, so negative, negative, and this is what we put into our parentheses, x minus 5, x minus 1, and I'm done. That rhymes, okay? So that's factoring if I have 3 terms with the number in front of the x squared being a 1. Here I only have 2 terms, so what we want to do is we want to see if these can be, okay, they're perfect squares. So then I double bubble. To get 9, 3 times 3 gives me 9. To get x squared, x times x gives me x squared. To get a 25, 5, and 5. And when I multiply these, I have to get a negative, so one has to be a positive, the other one has to be a negative, okay? And I'm done. So that's our do now. This is just to kind of help you. So this stands for difference of, oh, my doggy. Yeah, so this one right here is perfect squares. So difference of square terms. Okay, this one right here is factoring with a trinomial with a equals 1. Number in front is a 1. This one right here is still a trinomial, but it's the a is greater than 1. This one right here, there's a couple of things, right? GCF, there is a greatest common factor here, which specifically is 4x, and if I factor that out, I get x squared minus 2x plus, to get 16, 4. So that's going to be greatest common factor as well as some trinomial factoring. And this last one right here is, if I have 4 terms, this is called factoring by grouping. Okay, 2 terms at a time. So this one right here, we are going to skip model problem number 1 for right now and do model problem number 2. So anytime you have 4 terms, you always split it in half, factor out the left, factor out the right, and then see what happens, okay? So split it. So I have between a 5 and a 15, a 5 comes out. And then between x cubed and x squared comes out, and I'm going to write down what's left. So 5x squared times what is going to give me 5x to the third. I have an x here, right? Why? Because if I divide this by 5, that's going to be an imaginary 1. And I have x squared here, so x cubed divided by x squared is just an x. If you can't see it like that, 3 x's on top, 2 on the bottom, cancel, cancel, 1 is left on the top, okay? Then I have a minus sign. I'm going to do the same thing here, divided by the same number, 5x squared. The x squareds cancel. 15 divided by 5 is 3. All right, that's the left side. Now I'm going to do the same thing, but with the right side. So here, between 4x and negative 12. I'm going to take out a 4. That's the only thing that matches. And what am I left with? X minus 3. And I can check that by doing distributive properties. So I get this back. Okay. There's a plus sign between it. So this is what always happens. Stay with me. Stay with me. All right. Let's go pink. See this x minus 3 and this x minus 3? Right? They're the same number. So all we do is we're going to take that x minus 3. Let me just go ahead and put it like this. And we're going to take that x minus 3 and we're going to factor it out, which means that we're going to pull it out. We're going to write down what's left. So if the x minus 3 is gone, there's just a 5x squared left here. If the x minus 3 is gone here, there's just a plus 4. So this is the answer completely factored out. Okay. I am going to go back and do the first one. So this one right here, x plus 1, then I have a number that's just a number by itself. So let's go ahead and just take this x plus 1 and put in like this, m equals x plus 1. So instead of x plus 1, I'm going to put in m. This is squared plus 5. X plus 1 again is m, right? Plus 6. So now I'm going to factor out what I have here, okay? So this is a double bubble. I'm looking for two numbers that multiply to give me 6 and add to give me 5. So 6 and 1, yes, but everything is positive. 2 and 3, looks like it works. 2 plus 3 is 5. 2 times 3 is 6. So I have m plus 2 and m plus 3. When I get to this right here, I'm going to replace my m with the x plus 1 again. So this is going to get replaced there, and this is also going to get replaced here. So what do I have? X plus 1 plus 2 and x plus 1 plus 3. So now I just simplified this, right? So x plus 1 plus 2 is the same thing as x plus 3. And here x plus 1 plus 3 is equal to x plus 4. And I'm done. And so I can prove that this works by taking this and like simplifying it. So x plus 1 squared is x plus 1 times x plus 1, forgive my handwriting, plus 5, right? I go like this, so that's going to be 5x plus 5 plus 6. So this, when I FOIL this out, is going to give me x squared plus 2x plus 1 plus the 5x plus the 5 plus the 6. And then here I'm going to combine like terms, so this is equal to x squared plus 7x plus 12. And if I double bubble this, I get x plus 3 and x plus 4, which is exactly what I got here. Okay. So technically you don't need to do it the first way. You could do it the second way and still get the same answer. Okay. Try some of the problems that are here, right? So the check for understanding is a little crazy. But what we're going to do is combine like terms and then simplify. Try that, give it a shot, look over it.